Okay, we're at lesson 1.2, and this is about dot plots. So how do you make a dot plot? So the first thing is you draw the axis. You kind of scale it, put some tick marks there. It's fine to do that by hand. And you want to label the axis with not just numbers, but also a title there, what it means, in this case, goals scored. And then mark the dots above the location where the data points are. So if there are 5 2s, you're going to put 5 points right there up above the 2. If they're 6 1, maybe put 6 points above the 1. And so this is for, again, last section we were talking about categorical data. This is quantitative data, so numerics here, representing counts. So that's just a classic kind of dot plot there. It's symmetric, so this is actually important. We'll talk about this all year long, just the shape of a graph. So in this case, we're looking at a dot plot. You can see that it's symmetric, or we like to say things like approximately or roughly symmetric. So it's certainly not perfectly symmetric. You can see the right has a little bit taller bars maybe at some points there, but or left at some point. So it's not perfectly symmetric, but it's roughly or approximately symmetric. When it goes down to one side of that, so you see how it kind of extends out to the right, and it has that value at the very end there. Probably not an outlier, but almost to be an outlier there. So we skews to the right. You kind of ski down that slope. You're skewing to the right there when it looks like that. And when it goes the other direction, then you're skewing to the left, or left skewed here. So since it's the left side of the graph, it's much longer, so it's kind of skewed to the left. So that's very important. We'll use that terminology all year long. So it's the long tail, not the most clustered part. So it's kind of like that, what may be an outlier or something. Okay, describing shape. So first we describe. So another thing we can say about shape is sometimes it's unimodal. So if it has a single peak, you see this one has a single peak there at 20. It's bimodal if it has 2 peaks. So this one has a peak at about 19 and another peak at about 45. And then it's approximately symmetric. Even if it's, in this case, it's not really going down on either side. We still get uniform, but it's almost flat at the top, or approximately symmetric. Okay, so you can describe by shape, center, and variability. And so it's helpful also to talk about outliers here. So always include context when you talk about this. So like you're talking about number of goals scored, or males or females, or whatever it is. So let's try one here. So describing distribution of goals scored in 20 games. In this case, how would you describe the shape? So the shape looks like it is skewed to the right, has a single peak at 1. And there's a little bit of a gap. So we didn't talk about that. There's a gap between the 5 and 9 goals. 6 and 8, there's a gap there. Are there any outliers? So that's the second thing we want to talk about. It doesn't have to be in order. But we need to hit these things. So 9 and 10 could be outliers. They're kind of unusual. They're far out there. Definitely possibly outliers. We'll figure out later on how to directly calculate outliers. What's the center? The median is something you actually can count. So you see there's 20 games here represented. So we want the 10th and 11th games. So the first bar there has 6 units. 7, 8, 9, 10, 11. So remember, if you include 1 and 2, that's the first 11. So the 10th and 11th term would be 2. Median is definitely 2. If you count it from the right-hand side, you got that 1 at 10, 1 at 9 at 2, 3, 4, 5. You got 3 more at 5, 6. You got 1 at 4, 7, 8, 9 at 3. So the 9 dots to the right represent 3 or more, but the 10th and 11th going to the right. And the middle value is 2 there. The number of goals going from 1 to 10 scored. So it's just how spread out the data is. Variability is the spread, and so it goes from 1 to 10. And it's somewhat spread out. We'll talk about different ways to talk about that later on. Did you include the context? Yes. Goals scored. Team. Right? So you want to use those kinds of words. If you don't, you won't get full pressure. Okay, so let's talk about these two. So household size here is on the x-axis. It is South Africa and UK. So see what the differences in household size are. I chose 52 from each country. Here are the dot plots. So let's compare the shapes here. And also when you do comparisons, which one is greater, which one is less? So which one is bigger, which one is smaller? Use those kinds of words. So in this case, the shape for the UK household is roughly symmetric. It's not perfectly symmetric, but there's not a ton of speed there. But the distribution of the South Africa definitely looks huge to the right. Maybe even an outlier. We'll talk about that in a second. They're over near 26 to 27. So it certainly doesn't look like any outliers for UK. There's no values that are far apart from wherever the median is, the mean there. The South Africa looks like it for sure probably has one at 27 and maybe one at 15 as well. That one's a little more iffy, but certainly one for sure at 27. What's the center? So the median should be easy to count with this kind of data. Okay, but you can type all those numbers in a calculator and you get the mean, but that'd be a lot of work. So the median would be the middle value. It looks like there were, so if you counted it, there's a lot. It doesn't tell so you would have to count how many total there are, find the middle number in that term. It looks like just roughly ballparking it. Looks like around 7-ish. I'm just guessing there. They said it was 6. I'm sure they calculated it was 6, but that's about where that median is, where that smaller peak is right there. And for the UK students, it seems almost for sure it has to be right about 4. You can count out the number of dots there that each puts in a data point and find the middle value there, which is the way to go. Variability. So right now we're just talking about basically the range from 3 to 27. That's a lot less spread out, a lot less variability. Maybe from 2 to about 6 there. Did you talk about context? And when I said 2 to 6, I said, 2 to 6 people, right? For the UK students. So always talk about the context and then use comparative language. So you notice I said that the UK has a lot smaller spread or variation. So those kinds of words like smaller or larger or bigger, those kinds of things are good words to use when you're comparing two distributions. So pair up and let's just try this verbally with your neighbor. Don't take notes on this. I want you to actually talk about these data pieces. This is for how many pairs of shoes does a typical teenager own? So evidently they took a sample of some females and males. This may surprise you. Well, we'll talk about it. So talk about it in context as in the number of shoes owned by males and number of shoes owned by females in those 4 areas. So start with, shape. What's the shape? Talk about it. And so after you talk about it, hopefully you said that the shape of the female shoe data is a single peak at around 13 there, and it definitely seems skewed to the right. Whereas the males have kind of a middle right around there, around 9-ish, 9 to 10 there, and it looks like it is also skewed to the right. So a similar shape in that sense. Although, so the outliers, maybe an outlier there at 58 for the female shoe data. For how many men? So one female has 58 pairs of shoes. It seems like a lot. So maybe that's an outlier, maybe it's not. I'm not sure. And for the male data, those last two seem like definitely probably outliers there, somewhere around 35 and maybe 39 there. For the male shoe data, so that means that a guy has about 38, 39 pairs of shoes. Center. So this is especially in this case we're comparing the center. If you thought median should be something that should be the easier one of the two to find. Let's just kind of ballpark it. The median of the male data is around 9 or 10 pairs of shoes. The median of the female data is definitely larger than the male, the number of shoes that the male has. So not sure, just ballparking it, probably be in the mid-20s there. Looks like they figured it out, they say it's 26. The variability or spread of the data here, so the number of pairs of shoes for female range from about 12 to 16 or so, and then the range of data for number of shoes for males is from 3 to about 38. Here's my dot plot. So this is I found out we're going to actually make a dot plot on our calculator. So if you do that, go to the home key and go to the app that looks like a listing spreadsheet. So we're going to go to the very top, right next to the letter A, we're going to type the mean. This is the fluid ounces of soda. Let me spell soda for soda data. Okay. So I'm going to put my cursor in cell A1. So in the table, just like Excel, it's going to be A1. So we're going to put 12.01, 12.08. Okay, so I have 12 pieces of data. You can see that it says A12 right there. I put in my last piece. Make sure your cursor out of this last cell. Sometimes people will do this, 11.97. These are calculated. If you don't press enter, the calculator doesn't know you entered anything in that cell. So press enter or mouse out of that cell for me. And now you're going to go the home key, up right there, and go to the data and statistics app. It looks kind of like a bar chart for physics. So we're going to choose it, kind of randomly just place a bunch of dots, labeled dots on your screen. If you click at the bottom, so if you hit tab or click down there, it says add variable. The only variable I have to add is soda. It magically makes a dot plot for me. Are you kidding me? It's crazy. Okay, so the question says, this is the number of ounces of a 12-pack. Company claims this can contain 12 ounces. Do these data give the person a reason to doubt that claim? So I don't know that you would doubt it from that. Although it does look like, 10/12 of the time you get at least 12 ounces. Then, 2/12. So 1/6. But it's close at least. At least you're not going to chip a lot. That's 11.96 relatively true in our case about how much variation and how many times they can get. And still have a product and not get it pulled from the shelves because companies, they don't want false advertising. The FDA so they have rules. But that's how we might talk about it. Okay. So a stem plot is a different one. You might have done a stem plot before. It's definitely possible. It's something I used to call seven. So this is what it looks like. So if you have a bunch of data, you make a stem. So the stem in this case are kind of like the tens digit, like 26, 2 is the tens digit, 55 is the tens digit. If you look at just the tens digit, it looks like we have no that start with 0. So 13, the smallest digit is 1, the biggest digit is 5. So we make stems like that. Personally, I'm different what this PowerPoint says. The PowerPoint says to go ahead and just make your leaves now. I would have put the numbers in order and then make my leaves. I like to do it that way. But what they did is, so what is a leaf here? So like this 9 here, right next to the 1. So that means the number 19. So these to the right, these are all the ones digits. So 19 means 3 means 13. 13 means 13. 13 means 13. 15 means 15. 26 means the number 26. 26 means 26, 24, 22, 23, 24. 3-1 means 31, 3-8 is 38, 3-4 is 34, and so forth. So you can see that this is representing just a list of data. So you would put it in the right order here, and then put a key. So like 4 bar 9 means the number 49. So if you see 4 bar 9, just going to pick up my finger there. It means there are 49 pairs of shoes in it. Now what's interesting, we talk about spatial names. So if you kind of turn this on its side, that order leaves and turn it on its side, you can kind of see it would be shaded or skewed to the right, I should say. So you can kind of see it's skewing towards the larger numbers there. That would be a skewed right graph. Sometimes you have males and females, and so we can actually do, you can split the stems. So when there's a lot of data, you split the stems. So what that means is split the stems is like there's a lot that start with 1s or 2s or 3s or 4s for the units. And so you've got a lot of stuff going on, so you can split it up so that it's easier to fit. So you put the lower numbers on one of the stems. So that first one has 0, 1, 2, 3, 4, and then the second stem for 1, with 1 in the middle there has the bigger numbers. And you can kind of split it out, so that's called a split stem, but it's also have a two-sided kind of stem and leaf plot. So we can see that on the left, that 3 means the number 13. The number in the middle is still the 10 value, right? So then to the right, that 0 to the right of the 1 there, that means the number 10 for male. So 13, 13, 13 are the first 3 values for female. So evidently, in this sample, 13 is the smallest number of shoes that that person owns. I own less than 13 pairs of shoes. I can confidently say that. Unless I do store, I don't throw away shoes a lot, so I do store a few in the garage for mowing the lawn, that kind of stuff. So I don't know, might be close. Leftover, used up pairs, I'm not sure how many I throw away. Probably should throw away more. But that's what a plot looks like. And you can see it's a little harder to see, but on the females, it's kind of backwards, but if you think about it, it's skewing towards the higher numbers there. So that is skewed right, and the males, it's more obvious to tell that it's kind of tilted 9 degrees left, and this is skewed right. Females, it's harder to see when it's written that way. It's right skewed. What would be the stem here? So if you had this data, like the number of gold medals scored here, you put them in order. I guess they're in reverse order right now, so I would like the 10s first, and then 21 last. So what would be the stem here? So I think the stems would start at 1 and maybe go all the way up to 12. So that's interesting. A stem can be a 2-digit number there. So you can see that that's how you would put this in there. So 1 all the way to 12 would be the stem. That's like your 10s digit, or kind of like your 2. You put 2 there when it's in hundreds. And then each of these numbers, so 1, 0 means the number 10. That's that first digit. 1, 0 is 10. 1, 1 is 11, and so forth. You see that the skewed right also included the key. 4 bar 1, the country was 41 total members. So we talked about dot plots with quantitative data, but you can also make what's called a histogram. In fact, let's just try and see what happens. So pretty wild, hit menu, go to plot type, and histogram is an option, and it actually changes your dot plot into a histogram. It automatically kind of figures out what bar size you want for that particular data, and usually does a pretty good job, but sometimes you can tweak that if you want to get into what you're thinking. But you kind of see it's roughly measured there for that data. So histogram has this kind of a look to it where the values are kind of a range of values down low and some kind of range. And then on the left is the frequency of that particular thing. So how to make a histogram? So you choose equal. So the key is you have to choose equal width. I like about 5 to 10, maybe 5 to 8 columns of data. So I like to split it into groups of 5 to 10, kind of. It's a good number of things to have there for how many bars can I go up on that. By the way, one little thing about the histogram is you notice it's different than the bar chart. Remember the bar chart was categorical? It were separate bars. Here there is an order to it. It's different, and it's touching. The bars are touching each other. So so it's a little different. So in this case, it makes sense to maybe every 5 values you might kind of break it up that way, because that makes 1, 2, 3, 4, 5, 6 bins there. Pretty nice. Make it to count up how many fall in each bin, so 0 through 5. So like Alabama falls into 0 through 5, whereas Alaska falls into 5 to 10 bins. So you kind of fill up those bins, count how many fall in each bin, and then you have the frequency table there. And then we can make our x-axis or our y-axis, take it off there, and label the tick marks. You can kind of break it up. So 0 through 5 is that first bin. So anything that first bar there, or bin, it's between 0 and 5. So there's 20 values that are between 0 and 5. Right? And then there are 13 values between 5 and 10. We don't know what those values are. So this is different than the dot plot, where you kind of look and see exactly where the median is, or you can even calculate the mean if you had to from a dot plot. We can't see the individual values. We really don't know what the numbers are just by looking. So it does give us a shape. A nice job of giving a shape. Thing. As far as the histogram, making a bin width here, so you could do 10 to 20, 20 to 30, and that would end up with kind of like that. Okay. Remember, histograms are with quantitative data, bar graph, or categorical. When I compare, oftentimes it's best to use the percents. Typically, for comparison, could be really nice. Just because it looks nice doesn't make it that's actually true all the time. Okay, that is our lesson for today.